Today we'll be talking about meat production methods, which is topic 5.7 on the land and water use unit. We'll basically be talking about identify the different types of meat production and describe the benefits and drawbacks of these different types. And be asked to look at data and explain the data. So there's something called a CFO, which is basically they're called feedlots, where they're packed in so tight that they basically can't move very much. They're fed grain to raise them as quickly as possible, even though they were evolved on grass. It maximizes land use and profit because this means most meat production per unit of area. Minimize the cost of meat for us, the consumer. However, because they give huge amounts of antibiotics and growth hormones to prevent disease outbreak and speed meat production that can cause problems later. The animals produce huge volumes of waste, which, if there's flooding, can contaminate nearby water or is soaked down into the groundwater. It releases huge amounts of CO2, methane, nitrous oxides, and it smells really bad. The first three, CO2, methane, and N2O, can lead to all greenhouse gases and lead to climate change. Now, there are something called manure lagoons, which are open pits where the manure goes and just sits in there. The waste contains ammonia, hormones, antibiotics, and fecal coliform bacteria, E. coli, which can get you very sick. Heavy rain can flood the lagoons, contaminate nearby surface and groundwater. The E. coli is toxic to humans if you get it in your food. Ammonia causes eutrophication. Antibiotics and growth hormones alter the hormone system of us and make it the bacteria more resistant to antibiotics. The denitrification of ammonia in manure produces nitrous oxide, which is extremely powerful greenhouse gas. These lagoons can be emptied and buried in landfills. Instead, the manure can be buried in landfills or turned into fertilizer pellets and be used on farms. Free-range grazing, however, is where the animals graze on grass and grow at a natural rate, but without the growth hormones. No need for antibiotics, doesn't require production of corn. Waste is dispersed over the land so it grows, and therefore it acts as a fertilizer instead of building up in lagoons. However, it requires more land per pound of meat produced. It's more expensive to us, and the animals can graze on land too dry for most crop use growth. However, we can get overgrazing. If we have too many animals there, such as what can happen, they will remove all the vegetation, which leads to topsoil erosion, tragedy of the commons. Animals can also, because they're walking over it and confined a little bit, can compact the soil, which will decrease water holding capacity and lead to more erosion. If there's too much other plants eaten, it can lead to formation of that area into a desert called desertification. And if it's too compact, water won't go in. So what needs to happen is there needs to be rotational, where you move cattle into one area, move them to another area, put pigs and chickens into that first area so that they can remove some of the manure from the cattle. And they also eat different things, so there won't be overgrazing. The rotation can also increase the growth of grass. You can also increase the growth of grass by distributing manure and flipping the grass back to the size where the growth is more common, and then feeding that extra grass directly to the animals. And so, as seen in this graph, if you cut the field at the grass growth rate right here where it's maximum, and keep it there. You might be able to use this if you collect it, use it in by the barn, and then this will continue growing very, very rapidly. However, meat is not very efficient. If we produce meat, it's less efficient as opposed to energy, land use, and water. Energy, all the energy needed to plant, grow, and harvest the plants to feed the animals requires energy. Energy needed to bring the water to the animals. Energy needed to house the animals. Energy needed to slaughter and package. All the land, all the energy needed to grow the plants to feed the animals, plus room the animals need to take. You can see with this picture that with crops such as soybeans, you get 356 pounds of protein per acre, versus beef is only 20. Water, all the water for crops that the animals eat, plus the water that the animals drink. And so the vegetables, grains that we could eat just by itself would only use 26 grams per protein, whereas beef uses 112. So it's not very efficient for acres of farmland, but it uses a lot of water. So practice FRQ. Explain an environmental benefit of eating a plant-based diet rather than a meat-based diet using the data below.